Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which helps us in printing levels of all the nodes in a binary tree iteratively. First, let us take an example. Level of node 1 is 3. Level of node 2 is 2. Level of node 3 is 1. Level of node 4 is 3 and level of node 5 is 2. Now let us see the algorithm. Let us also have a sample tree to test our algorithm. We pass the root node, which is 3, to function print level. So root will point to 3. Since root is not null, we create a queue to hold tree node with level. So first we enqueue 3 along with 1 for level. As the queue is not empty, we enter the while loop and make p equal to q.front and pop the front element from the queue. Next, we print the data and level of node 3, which is stored in p. Now we check if p has a left child. As it is true, we enqueue the left child of 3, which is 2, along with 1 plus 1, that is equal to 2 for level. Next, we enqueue the right child of 3, which is 5, along with 1 plus 1 for level. Since the queue is not empty, we continue with the while loop, and now p will point to 2, which is the front element of the queue. Also, we dequeue the front element from the queue. Now we print the data and level of p, which is 2. Next, we enqueue the left and right children of node 2 along with 2 plus 1, that is equal to 3 for level. We continue with the while loop as the queue is not empty. Now p will point to 5 and 5 will be popped from the queue. Next, we print the node's data along with its level. So 5 and 2 are printed, which is stored in p. As the left and right children of node 5 does not exist, nothing is enqueued and we continue with the while loop. Now p will be equal to 1, 3 and front of the queue will be dequeued. We print 1 and 3, where 1 is the node's data and 3 is the level of node. We continue with the while loop as the queue is not empty. So now p will be equal to 4, 3 and 4, 3 will be dequeued. Next, we print node's data, which is 4 along with 3 for level. Since node 4 does not have any children, nothing is enqueued, and now as queue becomes empty, we break out of the while loop and finish execution for this program. Now let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.